Greetings students. So we have this question that I've gotten from one of the previous past papers, particularly from the 2023 paper 1, additional mathematics. Okay, so the question reads, on the same diagram, sketch the graph of y is equals to modulus of cos x over 2 minus 1 and y is equals to 1 for the domain 0 is less than or equal to x, x is less than or equal to x. So we have been taught to graph the function y is equals to the modulus of cos x over 2 minus 1 and y is equals to 1. Okay, so we have these two functions. The first one is y is equal to modulus of cos x over 2, okay, modulus of cos x over 2 minus 1. Okay, so this means modulus. This means modulus. Okay, so this means that the value of y will be reflected to the positive values. The values of y will be reflected to the positive value. So if you find a negative value, just know that that negative value, it will be reflected to the positive values. Okay, because there is no negative of modulus. A modulus has no negative values, hence the negative numbers are reflected to the positive numbers. Okay, so this is one of the function that we have, and another one is y is equal to 1. Okay, so we have been taught to graph these two functions on the same diagram, diagram. Okay, so it's easy for you to graph this but not this. It's easy for you to graph this but not this. Okay, for you to graph this, you need to find what we call the amplitude, the frequency, the phase shift, in the counter value, then you graph. Okay, because this, you know, just this is just a straight line. Y is equals to 1 is just a straight line. So the first thing that you need to do here is to deal with this one, because this is easy to graph. So you have this function, which is so we're just going to wrap this so that we remain with this, but we shouldn't forget about that. We have just ignored it for a while. Okay, so we have this function. So the first thing that you need to do is to determine. You need to determine your amplitude. So amplitude is represented by letter A. Okay, I believe we know this because we have been doing these things together. Okay, so amplitude is represented by letter A. So A is equal to, I said that for you to find the amplitude, you need to get the coefficient of the trig ratio, the coefficient of the trig ratio. So in this, if you see the coefficient of the trig ratio, you are going to find out that here there is no number, so this means that there is 1 here. So there is 1, so our amplitude hence will be 1. Okay, then the frequency, which is represented by letter B. The frequency is represented by letter B. Okay, so the frequency, we get the number which is in between x and the trig ratio, x and the trig ratio. So in this case, there is 1 here in between, so I'm going to get 1. So there is 1 in between. So this is our frequency. Then lastly, we find the period. So period is given by the formula 360 over frequency. So our frequency is 1, so I'm going to have 360 over 1, and this will give us 360. So this means that our graph will end at 360, isn't it? Okay, so having found this, you also find the counter value and the phase shift. The counter value and the phase shift. We know that the counter value, which is represented by CV, is equal to 1 over 4 of period. 1 over 4 of period. So our period is 360. So we are 1 over 4 multiplied by 360. This will give you 90. So our phase shift, it's our counter value, it's 90. Having found the counter value, you now find the phase shift, which is the starting point of the graph. So phase shift is equal to C over B. C over B. Okay, so since here there is no angle, so this means that so first of all, before we proceed, I need to identify these things to you. So C stand for an angle given, the angle given, and B is the frequency, which is 1. So since here there's no angle, so this means that our angle is 0. So we're going to have our phase shift to be 0 over B, which is the frequency. So B, we found the frequency to be 1. Okay, so hence our phase shift will be 0. Okay, so having found this, you just now graph or draw what we call the trig table. We draw what we call the trig table. Okay, so this is the trig table. Then you just put a line here. Okay, this is our trig table. Then this side you put x, because we have x in this function, so we're going to have x this side, and this will have the whole function of y, which is modulus of course open brackets x over 2 minus 1. So there's a close bracket and modulus. Okay, so first of all, before we go further, I hope you have understood what this means. So 0 is greater than or equal to x, x is less than or equal to 2 pi. So pi is the same as 180. Pi is the same as 180. So 2 multiplied by 180, it's 360. So here they also mean that they just mean that 0 is less than or equal to x, x less than or equal to 360. Okay, so x shouldn't exceed 360. X shouldn't exceed 360. Okay, so after this, you now start to say that the phase shift is 0. So 0 is the starting point of the graph. So where there is we start because the phase shift is the starting point of the graph. So we're going to have 0 here. 0. After 0, to find the next value of x, we just add the counter value. Okay, so phase shift plus the counter value, it will give us 90. 90 plus 0, it will give us 90. Again, to find the next value for x after 90, you just add another counter value. So 90 plus 90, it will give us 180. Okay, 180. After the 180, to find another point that will be after 90, you just do 180 plus the phase shift. You just add the phase shift. So we're going to have 180 plus this will give us 270. 270, isn't it? Okay. After 270, we just add another 90 to find the other value of x, and this will give us 360. So 360. Okay, so since we have found this, we just now start replacing where there is x with these values. Okay, so where there's x, we place within these values. Okay, so the first point of x is goes to 0. So where there's x, we're going to put 0. Okay, so you are going to have cos 0 over 2 minus 1. So this is under the brackets. Okay, so you place on your calculator. Oh, these are modulus. These are called modulus. So you place on your calculator cos. So 0 divided 2 to give you 0. So you're going to place on calculator cos 0 minus 1. So you're going to find that the answer is 0, because cos 0 it's 1. 1 minus 1 to give you 0. Okay, to give you 0 here. Then you proceed to another point. Cos 90, where there's x, you put 90, so to be 90 divided 2, hence we're going to have cos 45. So cos 45 minus 1. So cos 45 minus 1, this will give you negative 2.9. Negative 2.9. Since this is a modulus, there is this, and this means that the modulus. Okay, so cos 45 minus 1 to give you negative 0.29. So remember, this is a modulus. This is a modulus. A modulus has no negative values. The negative values are pushed to the positive values. Okay, so we're just going to change this into positive. So we won't write as negative 0.29, we write as a positive 0.29. Then we just round off. 0.29 is the same as 0.3 if we round off. Okay, so we're going to have 0.3. So when you're dealing with modulus, just know that you won't have a negative value. Change that negative value into positive value. Okay, I'm trying by all means to be slow so that we all understand how to solve this kind of question, because this is 5 marks. Okay, so another point is x is equals to 180. X is equals to 180. So where there's x, we're going to put 180. So we're going to have x 180 divided 2, isn't it? 180 because we have x over 2. 180 divide 2, it will give you 90. So we're going to have cos 90 minus this one, minus 1, and this will give us negative 1, but we are dealing with a modulus, so that's negative. We just forget, we will just ignore the negative, and so we're going to have positive 1. Okay, so this has given us negative 1, but we have just changed it into positive. I hope you are following attentively. Okay, and the other point, or the fourth point, is 270. So where there's x, you put 270. So we're going to have 270 divide 2. This will give you 135. And then we have cos 135 minus 1. So cos 135 minus 1. This will give you negative 1.7, but this is a modulus, so we will ignore the negative, and so we're going to have 1.7. The last one, it's 360. The last one is 360. So where there's x, we're going to put this 360. So we're going to have 360 divided 2. That will give us 180. So I'm going to have cos 180 minus 1, cos 180 minus 1, and then this will give you negative 2, but we don't write negatives on the modulus. Okay, so whenever you see this, just know that I'm dealing with the modulus, and I won't have any negative number. Okay, so having written like this, you now graph. Okay, you now graph. So you're going to have your graph down here. So we're just going to graph it here. Okay, so this is our graph. So we have okay, so we just put this into the x-axis or the y-axis, because these points represents the values of y. Okay, so the first, we have 0 here, we have 0, so we're going to have 0 here. Okay, after 0 we have 1, then last we have 2 on top, 2 on top there. Then we just start graphing. Okay, so before you start graphing, put these values in the x-axis, because that represents the value for x. So we have 90. After 90, there is 180, then 270. Last one is 360. This is the last one. Okay, then you start graphing. So the first point you have 0, 0, 0, 0, which is here, 0, 0. So where is 0, 0 in our graph? So 0, 0, it's here. We have 0, 0 here. The second one, it's 90, 90, 0.3, 90, 0.3. So you come on 90, so 0.3, you just estimate where 0.3 can be. You just estimate where 0.3 can be. Okay, so during your exam they'll give you a graph to use. During the exam they'll give you a graph to use. So I'm going to solve one question on the same graph so that you understand on how to count it, or how to graph it on the graph. Okay, so 90, 0.3. So 0.3 we can estimate that it can be somewhere here. This is just an estimation. So 0.3 can be somewhere here. Okay, can be somebody below 1. Okay, the other one it's 180,1. So 180,1 it will be somewhere here. 180,1. Okay, after 180,1 we have 270,1.5, 270,1.7. so 270 you just estimate where there is a 1.7. so 270 1.7 is below 2, so we're going to have somewhere here. Okay, somewhere here, but below 2, so you can put it here. And the last one it's 360,2, 360,2, which is here on top. Okay, then you just draw the the line. So you just match these points. You just match these points. Okay, so this is the graph. Okay, so to make it look perfect, I'm just going to draw this. I'm just going to do a question on the graph so that we graph it properly. But see, I believe you are getting some concepts here, getting some concepts. Okay, so remember this, the graph we have drawn, it's for the modulus of y is equal to the modulus of cos x over 2 minus 1. Okay, so this is the graph, and we are taught to graph two functions. The other function that we are taught, it's y is equals to 1. Y is equals to 1. Okay, so this is the question that we had. Okay, so we had this question on the same diagram. Sketch the graph of y is equals to shan and y is equals to 1. So we have graphed this, so we have remained with the graphing this. Okay, y is equals to 1. So y is equals to 1 is just a straight line, so it's just going to come on your graph and graph where y is equals to 1. So y is equals to 1, it's here. Okay, so y is equals to 1, it's here. So we're just going to graph a straight line, okay, a straight line. Okay, a straight line. This is a straight line. Y is equals to 1. So we have graphed two functions, and this is what the question wanted us to do. Okay, so the other question that you find after this, they will tell you that after graphing, so after you have graphed, they will ask you that hence state the graph, state the number of solution for which cos x over 2 minus 1 is equals to 1. Okay, so this is another question, so I'm just going to write it down here so that you understand what I'm talking about. Okay, so we have another question which says hence states the number of solutions, for which modulus of course x over 2 minus 1 is equal to 1. Okay, so I've been told to state the number of solution for which cos x over 2 minus 1 is equals to 1. Okay, so first of all we had two functions. We had the first function, which is y is equal to 1, or modulus of cos x, modulus of cos x over 2 minus 1, and y is equals to 1. These are the functions that we had. Okay, so here if you see this is this and this, so they have just combined this to make this. Where there's y, they have just put 1, or where there's y here, they have just put this. Hence we have come up with this. Okay, so they are just telling us to find the number of solutions for this function, or for the combination of this and this. Okay, so for you to find the number of solution, just go on your graph. You just see where these two are meeting, where they are meeting. Okay, so if you see they are just meeting once, isn't it? Yes, they are just meeting once, and this is here. Okay, so we can say that this has one number of solution over 1. It has one number of solution. Okay, so the number of solution is equal to 1. Okay, so this is how you can do this kind of question. So these are the questions that are expected to come, but sometimes they bring questions like we were doing in the previous lesson. Okay, so I guess for today we'll end here. We'll proceed from where we have ended today. So in the group there's exercise on coordinate geometry. Please answer and submit your answers. I greet you.